Good morning, children. This is unit number 2. So in this we are discussing about kinematics. So on the go now we are starting the example starting with example 2.34. So an iron ball is used here, and another one is feather. So both are falling from a height from 10 meter. Both are falling from the height of 10 meter. So in this there are two questions here. One is, what are the time taken by the iron ball and feather to reach the ground? So we have to find out the time taken. Then what are the velocities of iron ball and feather when they reach the ground? So we have to find out the velocities too. And here G will be taken as 10 meter per second square, and we can ignore the air resistance. So we having the formula. So previously we derived that formula from the equation 2.8 in previous we derived the formula to find out the time taken when the object is moving, and time is equal to, we can write the formula 2h square divided by g in square root. So everything is given, the height is given 10, the h will be substituted as 10, then g also can be taken as 10. Now 10 and 10 will be cancelled, the rest is square root 2, and square root 2 answer we know 1.414 second. Then we can say that both the feather and iron ball reach the ground at the same time. And now following the equation 2.19, we are going to give answer for question number 2. And here the question is, what are the velocities? It's asked here. The velocity we can find from the formula 2.19. V is equal to square root 2gh. So what is the formula? V is equal to square root 2gh. This formula we derived 2.19. So previous page number 78 கொடுத்துருக்கேன். ஸோ நம்ம லாஸ்ட் கிளாஸ் இதை டெரைவ் பண்ணோம், உங்களுக்குலாம் தெரியும்னு நினைக்கிறேன். So from the 2.19 we are substituting the known values. V is equal to square root of 2gh is equal to square root of 2 into 10 into 10, then it will be square root of 200. Okay, then we can take square root of this, then we are getting the answer. எப்படி ஸ்ப்ளிட் பண்ணலாம்? easy way, we can split this value as square root 200 வந்து 2 into 100 ஸ்ப்ளிட் பண்ணிட்டோம்னா ஸ்கொயர் ரூட் குள்ள, then 110 வெளியே வந்துடும். So 10 into square root 2. So we know square root value, that is 1.414. Then you multiply this 10, you will get the answer 14.14 meter per second. It is unit for velocity. And here the Galileo statement is given. So Galileo concluded that in vacuum all the objects are fall with the same acceleration g and reach the ground at the same time. This experiment was done by scientist Galileo. Okay, and now we are moving to example 2.35. It is application related example, and question is it possible to measure the depth of a well using kinematic equation? So we have to find out the depth of a well using kinematic equation. So one boy is standing here and he is throwing a stone. He is having stop clock with him. So அந்த ஸ்டோனை ரிலீஸ் பண்ணும்போது he has to on the stop clock. கீழே போய் ரீச் ஆச்சு எப்படி நம்ம கன்ஃபார்ம் பண்ணுவோம்னா ஒரு சவுண்டு கேட்கும். ஸ்டோன் கீழே போய் ரீச் ஆனோடனே அது பாட்டம் போர்ஷன் ஆஃப் த வெல்ல போய் ரீச் ஆனோன்னா ஒரு சவுண்ட் we can hear. So when we are hearing the sound, we can off the switch of the, we can stop the stop clock. It will shows the time, so how much time it taken to reach the ground. So using that we are going to derive the derivation for this. So we are going to find out the depth of this well knowing the known formulas, so which we derived in previous classes recently. And when he released the stone, அப்போ ஸ்டோன் பார்த்தோன்னா ஸ்டார்டிங்கில் ரெஸ்ட்டில் இருக்கும், then just he is left it move to down, and it is moving down because of the acceleration. And we can say the initial velocity at first is 0. Okay, then now we are writing the equation s is equal to ut plus half at square. ஞாபகம் இருக்கா? இந்த equation நம்ம derive பண்ணோம்ல, second equation of motion second derive பண்ணோம். s is equal to ut plus half at square. This is the equation. Then what about u? U will be taken as what? 0. Okay, then a can be taken as z, and inga g pathana it is moving down. We discussed here for gravitational moment it is exception we can use as positive j cap. Usually இது x இது y அப்படின்னா this is minus y வரும், இது minus x வரும். The object is moving along the minus y, but even we are taking as plus. it is exception is given. And see here in this derivation, so we got from the previous equation, so s can be replaced by what? D. Okay, s is nothing but what? Displacement, and it is displaced by the term D, and u is 0, then ut will become 0, then half at square is the formula. So a is substituted as what? G. Then a is G now, half gd square is the formula here. Okay, and substituting the G value, we get the depth of the well. Okay, and T we can find with the help of that stop clock. So when we know T and G is known value, it is a standard value, we can substitute, then we can find out the answer. And to find out the error, to minimize the error and to get the accurate answer, we are using the formula error is equal to D error minus D. Okay, and using the rope we are finding that error, and relative error we can write as D error minus D divided by D error, then percentage error, just it is the multiply, this value is multiplied with 100. Okay, and this error may acquire and the sound on அந்த பாய்க்கு கொஞ்சம் லேட்டராக கேட்டிருக்கலாம் அந்த ஸ்டாப் கிளாக் ஸ்டாப் பண்ணது கொஞ்சம் டைம் எடுத்துருக்கலாம். ஸோ டியூ டு தட் சம் எரர் மே அக்வயர். ஸோ we are repeating this experiment and we can find out we can take 4 or 5 values. That average will give the accurate value in this to find out the depth of the well. Okay, this is the easy experiment which is given in this example. And see the note, if water is there means the method can be used to measure the depth of the well till the surface of water. ஏன் அப்படின்னா எவ்வளோ வாட்டர் இருக்குன்றது வி கான் ஜட்ஜ் ஹியர், நம்ம மேலே இருந்துட்டு அதை ஜட்ஜ் பண்ண முடியாது. ஸோ மேலே சர்ஃபேஸ் ஆஃப் த வாட்டரில் படுற வரைக்கும் we can find out the time, then we can find out the depth. Have you understood, children? Yes, it is easy method. Okay, and next we are moving to case 2. So last classல case 1 பார்த்துட்டோம். So this is case 2 and here we are considering the object of mass m, the ball mass of m is thrown upward. ஒரு பாய் இதில் ஃபிகரில் கொடுத்துருக்கு, he is throwing the ball in upward direction. So upwardல போனால் we have to give some initial velocity, so that will be taken usually u. Final last என்னவா எடுத்துக்குவோம்? V, அது நமக்கு தெரியும். So it is u and we choose the vertical direction as positive y axis as shown in the figure. Then the acceleration we can take as minus g. Why it is minus g? This ball or this object is moving against the gravitation. It is moving what? Against the gravitation, then it is taken as minus. And also the assumption is we are taken the friction of air will be taken as negligible. Okay, and now the velocity and position is fine with the help of that formula. We are using all the 3 equations. So what is the first equation? V is equal to u plus at. So what is the first equation? V is equal to u plus at. This is the first equation. உங்களுக்கு நல்லாவே தெரியும்னு நினைக்கிறேன். Then we are writing V is equal to u is substituted as u, then a can be written as minus g. ஏன் minus g எழுதுறோம் அப்படின்னா a is nothing but acceleration. Here the acceleration is given by gravity, and also it is acting what direction? In opposite direction, t. And then we are using the second equation, and now the second equation is s is equal to u t plus half at square. இப்போ தான் நம்ம லாஸ்ட் டெரிவேஷனில் பார்த்தோம். And see here last example பார்த்தோம், and we are substituting here s is equal to ut, then a will be taken as g here. Okay, a என்றது what? Acceleration. இங்கே யார் acceleration தராங்க? g என்றது acceleration தராங்க. When it is moving upward it is minus, then minus half gd square. This is equation number 2.21. So like that the 2.22 we are getting from third equations of motion. So what is the actual equation there? V square is equal to u square plus 2a s. Okay, so V square is equal to u square plus 2ay. This is the equation we got in third derivation, that is we got as in the equation 2.9. and here 2 changes we are making. One is same, V square is equal to u square, a will be taken as minus g and s is taken as y. Then we can write the equation V square is equal to u square minus 2gy. Here minus g because of the acceleration is acting against the gravitation. அதாவது இந்த பால் எப்படி மூவ் ஆகிட்டு இருக்கு? against the gravitation மூவ் ஆகிறதுனால we are taken a as minus g. Okay, and we got the 3 equations in equation number 2.20, 2.21 and 2.22. and this is the condition of case 2 when the body thrown vertically upward direction. Okay, so what direction? vertically upward direction. Okay, so understood children? Yes, good. Next is example 2.36, and in this example 2.36, first we will understand the question. A train was moving at a rate of 54 km per hour. Okay, it is given kilometer per hour. First we have to convert into meter per second. When brakes were applied, it can be rest within the distance of 225 meter. Then calculate the retardation. So retardation means opposite to acceleration. Okay, or we can say deceleration, reducing acceleration, or we can say negative acceleration produced in the train. Our brake apply பண்ண speed reduce ஆகுது, and we have to find out that acceleration, that means that retardation. So it is a very simple, and you see the first step, it is the conversion of kilometer per hour into meter per second. தெரியும்ல கிலோமீட்டர்னா it is kilo is 1000 and meter per secondல, அப்போ per second அப்படின்றப்போ that is 3600. per hour வந்து நம்ம செகண்ட்ஸாக மாற்றுறோம். we are cutting these two zeros, then 5 2 times, then 18 2 times. okay, அதுதான் இங்கே நம்ம எழுதியிருக்கோம். so after converting kilometer per hour into meter per second, we got this the step, and after substituting that 54 into 5 divided by 18, after solving the equation, we are getting the answer as 15 meter per second. okay, and the distance is 225 meter. Here we are using the equation, third equation, and third equation is v square is equal to u square plus 2as. v square is equal to 2as. it is the deceleration, then acceleration is taken as what? minus. then we are substituting. so final velocity, train கண்டிப்பா, so final velocity na final train என்ன ஆக போகுதுன்றத final velocity, definitely it will become a rest. then final velocity will be taken as 0. then initial velocity பார்த்தீங்கன்னா நம்ம எடுக்கிற calculationலேருந்து அது என்ன வேல்யூவாக இருக்குன்றத நம்ம எடுத்துக்குவோம். so initial velocity is given in kilometer per hour. எப்படி மூவ் ஆகிட்டு இருக்குன்றத நம்ம initial velocity எடுத்திருக்கோம் at that particular time, that is 15 meter per second. we are substituting u square is 15 meter square, sorry 15 square minus 2a only we have to find out. yes is given 225. இப்போ அது கிராஸ் மல்டிப்ளிகேஷன் பண்ணுறோம், சாரி லெஃப்ட் அண்ட் ரைட் நம்ம ஆல்டர் பண்ணுறோம். தென் a cross multiplication, then we are finding the answer. a is equal to 0.5 meter per second square, and this is what? this is called as retardation, and this retardation value is 0.5 meter per second square. okay, it is very simple children. ஒன்றும் பெரிய டெரிவேஷன்லாம் இல்லை, சிம்பிளாக நீங்களே இதை ஒர்க் அவுட் பண்ணி பார்த்துக்கலாம். ஓகே, அவ்வளோ காம்ப்ளிகேட்டடான ஒரு எக்ஸாம்பிளும் இது இல்லை. okay, very easy example. and now we are moving to projectile motion. it is the next topic. so in this projectile motion, we can define whenever an object is thrown in the air and let it be to move under the gravity alone, this is called as projectile. okay, so we can say the projectile, ஒரு person வந்து he is standing top of the hill, இங்கே நின்றுருக்காருன்னா he is throwing the ball in this like parabola அப்படின்னா this is called as projectile. ஒரு ஹெலிகாப்டர் போயிட்டுருக்கு, ஒரு ஆப்ஜெக்ட் வந்து ட்ராப் பண்ணுறாங்க ஸ்ட்ரைட்டாக அப்படின்னா it is not a projectile. so it should move with certain angle. okay, it should carry with both the velocities, both horizontal and vertical velocities, then only it will be satisfied. understood children? and the path followed, so எந்த பாத்தில் இந்த ஆப்ஜெக்ட் போயிட்டுருக்கோ that is called as trajectory. okay, and some examples are given. one is an object is dropped from the window of a moving train. so திரும்பவும் சொல்கிறேன், மூவிங் ட்ரெயின்லேருந்து ஒரு ஹரிசான்டல் வெலாசிட்டி ப்ளஸ் vertical velocity சேர்ந்து போனால் மட்டும்தான் it is applicable here. okay, and then a bullet fired from a rifle, a ball thrown in any direction, a javelin, a jet water, all are the examples are given here. okay, and next is when this object is moving projectile, it having the two velocities. one is uniform velocity, it is acting horizontally. this uniform velocity is uniform till it reaches the ground. this is the first point. and second is the uniformly changing velocity, that is called as vertical velocity. it will be changed time by time, but uniformly. these two things are happening in this projectile motion. and there are two types of projectile motion. one is it is moving along the horizontal direction, and next is it is moving with an angle to the horizontal direction. so we are throwing the object with certain angle. So these two motions are there, these two types of projectile motions are there in this. And while studying this motion of projectile, we have to assume that there are three assumptions are given. One is air resistance is neglected, so we won't bother about resistance of air. Next is this effect due to the rotation of earth and curvature of the earth is negligible. So earth rotation, curvature of the earth, we won't keep it in our mind. Then acceleration due to gravity is constant in magnitude and direction at all points of the motion of the projectile. Okay, these three. So the acceleration means it is moving under the gravity. So that only we are considering here as the constant throughout the motion of this projectile. Okay, so all these three are taken in our mind while calculating the projectile motion. Okay, and next, first we'll study about projectile in horizontal motion. So what effect it is giving in horizontal motions? Here we will discuss with this help of this diagram, and check this diagram 2.39 and see the picture, and both are representing the same. So one person is standing at the top, okay, top of the hill or top of the building, and he is jumping and see his path like a parabola. And like that, here one object is thrown, it is moving like this, it is not moving straight move, it is not a projectile, it is moving with some curvy track. Okay, so at the time wherever we take the position of the ball, it gives the horizontal in the particular position mattum horizontal velocity is acting like this, and the point la vertical is acting towards the ground. Okay, அதே மாதிரி எங்க எடுத்தாலும் there is a horizontal and vertical until it reaches the ground. So reaches ground, after reaching the ground there is no horizontal and vertical velocities. சரியா? அப்போ இதில் பார்த்தோன்னா ஆல்ரெடி டிஸ்கஸ்டு என்ன டிஸ்கஸ் பண்ணோன்னா the horizontal velocity is always uniform, but vertical is not a uniform, it is changing continuously. Okay, so these things we have to keep. And now we can say the object is thrown in this first diagram. Say the object is placed at a height of h, that will be taken for displacement. So it is the starting point, we are throwing the object in the parabola, it reaches the point A and it gives the path is OPA. So what is the path it is giving? It is giving the path of OPA, and from the ground this A is giving the distance of x. Okay, so it is trying to explain about the horizontal motion, and here this horizontal velocity is compared with the x-axis, this is x-axis now, and vertical velocity is compared with the y-axis. Okay, xy நம்ம படிச்சிருக்கோம்ல, so gravitation பொறுத்த வரைக்கும் when it is moving down it is taken as positive, it is given as exception here. Okay, and it is the y-axis and it is considered as the x-axis. So horizontal is taken along this direction, it is considered as the x-axis, and now we can write the velocity along the horizontal component is ux, and vertical component we can write it starts with vy. Okay, these two things we are taking. So first we are taking the object is moving along the horizontal direction, so the particle has zero acceleration along the x-axis. So when we are taking the horizontal direction, so along the horizontal, okay, when we are comparing with the horizontal direction, it is not giving any acceleration here. Okay, it is the constant, it is moving with the constant velocity. So when it is moving the constant velocity, we can write the distance traveled by the projectile of an object in a time t, we can write with the formula. So what we discussed in second is s is equal to ut plus half at square. So இங்கே s க்கு பதிலாக it is along the horizontal அப்படின்றதால we are taken as x, and initial velocity is taken as ux, and acceleration here is taken as a, and time taken is t. Then we are substituting all the known terms. S is equal to ut plus half at square. So s is equal to, we can write as what? U. Then ut we can write as uxt half at square. Okay, and since the acceleration is 0 here in horizontal, the acceleration is what? 0. Then we can write a is equal to 0. Then this equation will becomes half at square will become 0. Then the equation we can write as x is equal to uxt. This is what? This is equation number 2.23. Now in this case we are taking the motion along the downward direction. So when we are taking the motion along the downward direction, So here we are considering only acting in downward direction, then we can write the initial velocity. So டாப்பில் பார்த்தோன்னா initial velocity definitely will be a 0. ஆனால் நம்ம கீழே இருந்து ஒரு ஆப்ஜெக்ட் மேலே த்ரோ பண்ணும்போது initial velocity 0வாக இருந்துச்சுன்னா that object will not move upward. ஓகேவா, இது நம்ம மைண்டில் வச்சுக்கணும். Then uy we can take as 0 when we are starting, but horizontal having some velocity. Okay, and a we can take it is due to the gravitation, and we are taking positive, we know what is the reason. And same formula we are writing here, s is substituted as y here, then u is taken as uy, then half at square. Okay, and uy is 0, then first half is 0, then the rest is y is equal to half gd square. A is substituted as what? G. And we are substituting the t from the previous equation 2.23. So what is 2.23? We got x is equal to ux into t. We got no, what we got in 2.23? X is equal to ux t. Okay, and from that what is t? Then we can write t is equal to x divided by ux. இது வந்து 2.3 ல இருந்து எடுத்திருக்கோம். So in this t we are substituting. Then we are writing the equation. So what is t? X divided by ux. So here we are substituting half gt square பதிலா என்ன substitution பண்ணுறோம்னா x square x by ux already square இருக்கிறதுனால x square by ux square. ஓகே, இதில் கான்ஸ்டன்ட்டை ஃபுல்லாக நம்ம தனியாக எடுக்கிறோம், தனியாக எடுத்து வச்சுருக்கோம். g is constant, gravity 2 is constant, ux is constant. சரியா, ஏன்னா horizontal velocity is always constant from starting point to ending point. And these three terms are constant, then we can take the constant is k. The next equation will become y is equal to kx square. So k is what? It is constant. That k value is what? G divided by 2u x square. It is a constant. Then this equation 2.25 is nothing but equations of parabola. So then we can write the path followed by the projectile parabola of the curve OPA is clearly shown on the figure 2.39. Okay, have you understood, children? இதோட நம்ம கிளாஸை நம்ம ஸ்டாப் பண்ணிடுவோம். அண்ட் ரெஸ்ட் வில் டிஸ்கஸ் இன் நெக்ஸ்ட் கிளாஸ். ஸோ இன்றைக்கி நீங்கள் எதை தரவு பண்ணுறீங்க அப்படின்னா, யூ டேக் திஸ் எக்ஸாம்பிள் 2.36. ஓகே, இந்த 36 சம் ஃபுல்லாக தரவு பண்ணிவிட்டு ஒரு டைம் எப்படி ஒர்க் அவுட் பண்ணுறதுன்னு பார்த்துட்டு தென் யூ டூ திஸ் சம் ஆன்சர் இன் யுவர் ஹோம்ஒர்க் பார்ட். ஓகே, தென் வழக்கம் போல் அதை ஃபோட்டோ எடுத்து சென்ட் பண்ணுங்க. ஓகே, தேங்க்யூ சில்ட்ரன்.